Hello! Today we have a battery with a blown fuse. I'm going to show you how to diagnose this issue without opening the case and then exactly how to repair it. The first question is, how can we know the fuse is blown without opening the battery case? We will use the NLBA1 analyzer to find out. Let's connect the battery to the analyzer. Then, start reading the battery parameters. We need to check the lock status and the current parameter. If the battery is unlocked but shows zero current, the fuse might be blown. Usually, if there is current, the NLBA output LED should be on, and the current is actually the current consumed by the output LED. In our case, the LED is off. Note that the current depends on the battery voltage. In some situations, when the battery voltage is low, the current could be too low to be measured, and that's why it could show current equal to zero. Let's try to charge it. As you can see, no current flows. One last verification on the reset tab. We must ensure there are no flags in the PF status register. As you can see, the bits are all zeros, which means there are no permanent failure recorded. Since there is no permanent failure flag but no current flows, we know the fuse is blown. Let's open the battery and check it. Here is what the bottom view of the fuse looks like. This green part is the heater, controlled by a power MOSFET. Its job is to blow the connection between the conductive plates if the chip detects something's wrong. Note that only serious safety issues could lead to a fuse blow, not every minor failure. As shown in the wiring diagram, normal current flows from terminal 1 to terminal 3. When the chip triggers the fuse blow, it melts the link between these points, completely cutting off the current flow. To fix this, we simply need to restore that connection. It is safe to do it using a soldering drop because the fusing current is high enough to melt the solder if necessary. The current is supplied directly by the cells. To visually identify a blown fuse, let's look at the comparison pictures. The image on the left shows a blown fuse, while the one on the right shows the same fuse after a repair. Now, let's move on and fix our fuse. We first need to remove the protective plastic cover. I'm using tweezers for this. With the cover off, we can see the fuse contacts. This is how a blown fuse looks like. Now, I will show you how to confirm with a multimeter if your fuse is blown. There are two methods to check it. First method. Set the multimeter on continuity mode. Place the probes on the fuse terminals 1 and 3. If it beeps, it's good. Ours, it's silent, so it is blown. Second method. Switch to voltage mode. Connect the black prong to ground. I am using the VG point, which stands for voltage ground. Next, use the red probe to measure both sides of the fuse. If the fuse is good, the voltage should be equal on both sides. In our case, we have 6.4 volts on one side, but 0 volts on the other. This confirms the fuse is definitely blown. Let's fix the fuse now. I will apply some flux and solder across the fuse terminals to bridge the connection. The fuse is now soldered. Let's see if it works. I'm switching the multimeter back to continuity mode. Let's touch the probes to the terminals one more time. And there it is. That beep confirms we have continuity again. The circuit is now closed and repaired. Now I will mount the protective cover back on. And now I will reconnect the battery to the NLBA. You might not notice it because it's quite dim, but the output LED is actually on. If we check the software readings, we see the current is still at 0. That explains why the LED is so dim, due to low battery voltage. But the real test is trying to charge the battery. Look, current is rising. This means the fuse is working properly. That confirms the repair was a success. Thank you for watching. If you have any issues, feel free to post on our dedicated forum. Don't forget to like and subscribe. See you next time.